In today's lesson video, we're going to talk about day 6.2. We're going to be talking about circumference and area. Now, these are probably things you may remember from previous courses, but again, we're going to focus on using them with what we've been talking about. And we're going to kind of build on that prior knowledge. So when we start off with, when we talk about area, area is just the amount of flat space a circle takes up. And there's a formula we use for area. That area formula is A equals pi r squared. Now, pi is about 3.14. It's a designated value we use with circles, but we're always going to use the pi key on the calculator. So I'm going to show you that as we go through this to make sure that you understand we're not just using 3.14 for pi. We're going to use the pi value of our calculator. Okay? And we also talk about a circle's circumference. And we mentioned this in the previous lesson. The circumference is the distance around the edge of the circle, and that has a formula as well. That formula is C equals pi times D for diameter. D equals diameter, and R equals radius. Okay? And so these are formulas we're going to use as we go throughout this lesson. But first, I want you to look at the relationship between radius and diameter. Okay, a radius is half of the diameter of a circle, and the diameter is double or twice or 2 times the radius. Okay. Diameter equals 2 times radius. Radius equals half of diameter. Okay, so we also could write our our circumference formula as circumference equals 2 pi r. That's another circumference formula you might see and use. So we're going to start off just with some basic examples where we use those formulas to calculate some measures. So let's start off with number 1. Given the radius of 13 feet, let's find the area. So we're going to use the area formula. Area equals pi times radius squared. And the radius is 13, so that's just pi times the radius of 13 squared. And then we can plug that into our calculator. You could do 13 squared, hit equals, then times pi, or you can plug it in all at once. Okay. So if that's the case, we'll do pi. Now to find pi on our calculator, it's on this calculator, it's the second feature of the exponent key. So I hit second, and then this exponent key here, and it brings up the symbol pi. Okay, if you have trouble finding it in the calculator, make sure you send me a message and ask, and I can usually show you on your calculator where to find that. Okay, so pi times our radius of 13 squared, hit our squared button, and then hit enter. Please remember, squared does not mean times 2. Squared means times itself. Okay, so it's best just to use the squared key of the calculator. Okay, so that's 530.9. It might be hard to see on my screen. Okay, so pi times 13 squared is 530.9. Okay, and that is in square feet for unit of measure. For number 2, we're given a diameter. Sorry about the bell. We're given a diameter of 20 inches and they want us to find the circumference. So we use the circumference formula. Circumference equals pi times diameter. So in this case, that's just pi times 20. And if we plug that into our calculator, pi times 20 is 62.8. Again, it might be difficult for you to see there. Not sure if my face is showing up with that or not. Okay, 62.8 square, just inches, not square inches. Okay, circumference is what we call a linear measurement or one-dimensional. 1D. Area is a square measurement or 2D. Okay. All right. So number 3, this time I give you an area and I ask you to find the radius. Well, all we have to do is take that same formula area equals pi r squared, but this time we're going to plug in for a and work backwards and solve for r. So we start with our formula and then we replace a with 132 because that's the given area equals pi r squared, and we want to get r by itself. So the first thing you should notice is we got to get rid of the pi. Okay, remember when you solve equations, we're working backwards, so we want to work backwards through PEMDAS. So we're going to undo our multiply by pi before we undo our exponent of 2. So we divide by pi to cancel it. Gets rid of it on that side. So we have 132 divided by pi. I'm going to go ahead and get a decimal value for that. 132 divided by pi. It's about 42.02. We'll just call it 42.0 is equal to r squared because pi canceled on that side. So now we're going to take the square root to cancel r squared. Remember back to Pythagorean theorem, to undo something squared, you take the square root of both sides. So I'm going to do the square root of 42. Second square root of 42, it's about 6.5. So the radius of this circle would be about 6.5 centimeters. Okay, let's keep going. Number 4, again, I'm giving you the total measurement, in this case circumference, and we want to work backwards to find diameter. So we start with the formula. Circumference equals pi times diameter. This time I know the circumference, I know c, so I'm going to plug in there. 121 for c equals pi times diameter. So to work backwards, all we have to do is divide by pi. And so if I do 121 divided by pi, I get about 38.5. So my diameter of this circle is 38.5 miles. Okay, so let's keep moving. Now the most challenging part of these examples working with formulas is these next problems, or are these next problems. As you work with these next ones, you'll notice I give you a total measurement again, like in number 5, I give you the area. Area equals 32.23, but I tell you to find the other total measurement, the circumference. So here's what we're going to do, and I'm going to kind of give you a little picture diagram here. We're going to start with one of our totals. We're going to go around from that and find the radius or diameter, and then we're going to work to the other total like this. Or we might do that backwards. Start with one total like the circumference, find the radius or diameter, and go back and find the area. Okay, so we're going to work their formulas here. Since I start with the given area, I'm going to start with the area formula. Area equals pi r squared. So I use that given area like I did on number 3. In this case, 32.23 equals pi r squared. And I'm going to find r based on that. So let's work through that. Let's divide by pi first. .23 divided by pi is 10.3. That equals r squared because pi is canceled. Now we take the square root. So I'm going to take the square root of 10.3. Okay. And I get 3.2. So r equals 3.2. But that's not my final answer. I want to use that radius to find the circumference. Okay, there's 2 ways to go about this. What I'd recommend is just changing radius to diameter first. Okay, since the radius is equal to half the diameter is 2 times the radius. So the diameter is 2 times 3.2, or 6.4. Okay, then I can use my circumference formula, pi times diameter, or pi times 6.4, and I can get my final answer by just multiplying 6.4 by pi. 6.4 times pi is 20.1. So my circumference with a radius of 3.2 ends up being 20.1 inches. Okay. All right. On this one, we are given the circumference this time, and we want to work backwards and find the area. So again, we're going to start with the circumference, pi times diameter. That's going to give me the diameter, okay? But then I need to divide the diameter by 2 to equal the radius. Okay, so when I find the diameter, I'm going to divide by 2 to find the radius and then use that to find the area. Okay, so 48.6 equals pi times diameter. Divide by pi. .6 divided by pi. Oops, let's try that again. 48.6 divided by pi is about 15.5. So I'm going to divide that by 2 to find my radius. Okay, I'm dividing that diameter by 2. 15.5 divided by 2 is about 7.75. We'll just call that 7.8. Okay. If I'd used my original measurement, it would be closer to 7.7, but we'll use this time. So the area formula then is pi times radius squared. So that's pi times 7.8 squared. And that's what I plug in the calculator. Pi times 7.8 squared is about 191.1. Square feet. Okay. All right, let's continue right along and take a look at the next set of examples. These next two big ideas are called arc length and sector area. So I'm going to explain what these are. In the previous lesson, we looked at arcs and we talked about arcs having a measure. Okay, well, arcs have measure based on degrees, but they also have a length based on a portion of the circumference. Okay, an arc's length is equal to a portion of the circle's full circumference. It's the measurement of what we call an intercepted arc. Okay, this angle here creates what we call an intercepted arc. Okay, so this arc, we'll just call it from A to B, has a measure in degrees that's equal to this angle measure in degrees. Okay, but the arc length is a portion of the full circumference. Okay, and so we're going to look at how to find that. But also, when you take that angle, and you draw the arc that it makes, what we call the intercepted arc, you get a two-dimensional region of the circle called a sector. And that sector has an area, a square space amount that's taken up, that is a portion of the circle's overall area. Okay? And so we're going to look at these portions using proportions, equal ratios. Okay? And so this is kind of what we're going to do. We're going to look at this formula here that has 3 parts to it. So this proportion has 3 parts to it, but really we're just going to use 2 parts at a time. We're going to use the left side, okay, meaning this side here, when looking at arc length, or when finding arc length. Okay? But we're going to use the right side, or the right 2 parts of this, when finding sector area. Okay? So we're going to use our radius that they give me and the angle measure they give me to find each of these. And when we're solving for either what we call arc length, we're just going to call L, and sector area we're going to call S. Okay, so that actually creates two separate proportions we can use. I'll write them separately for you. It might make a little more sense. So when finding arc length, the proportion you're going to use is L over, instead of circumference, I'm just going to use the 2 pi r. 2 pi r because I'm using radius most of the time. L over 2 pi r must equal the angle measure, which we're going to call x, out of 360. Okay? When doing sector area, we're going to use S over the area formula, pi r squared, equals x out of 360. This x out of 360 tells you what amount of the circle we're using, or what portion of the circle we're using. Okay, so as we look at this, we're going to apply either one of these to the problem we're using. In this first example, circle A, so I'll call it circle A by naming the center point A, has a radius of 14 inches and a central angle of 132 degrees. So I'm going to draw an angle that appears to be about 132 degrees. Nice obtuse angle, 132. And the radius is 14. So that arm is 14, that arm is 14, and it creates this arc. I want to find the length of that arc. Well, I'm going to use that proportion. Okay, so I'm going to go ahead and write it here. I'm going to write L for arc length over 2 pi r has to equal the central angle measure of x over 360. Okay, so the arc length to its full circumference has to be proportional or equal to the central angle 132 to the full 360. Okay, so let's plug in what we know. We don't know arc length, that's what we're looking for. We do know the radius is 14. Radius is 14, x is 132. So 2 pi times 14 has to equal 132 out of 360. And we solve proportions by cross multiplying. Okay, so I'm going to work all this out. I'm actually not going to condense everything together. I'm not going to do the calculations until the very end. So I'm going to do 360 times L for that cross product equals 132 times 2 pi times 14, or 2 times pi times 14. That's the other cross product. Again, we're looking for L, right? We're trying to get L by itself. So to get L by itself, on the left, we divide by 360. So on the right, we divide by 360. Cancel here. So this side ends up being what I put in the calculator. But I'll write that out for you. The arc length then equals 132 times 2 times pi times 14 divided by 360. And I can enter it in the calculator exactly like that. Okay? So that was 132 times, look again, 2 times pi times the radius 14 divided by 360. And we get about 32.3. Okay, so that's about 32.3, and we're using a unit of measure inches. It's arc length, so it's a linear measurement, just inches. Okay, let's try another one. Number 2, this time it says find the area of a sector. Okay, so now we're going to use this formula. Okay, so our sector, I'll kind of draw that out for you. We have a center of a circle again. We have a radius going this way. An angle of 51 degrees would be about that. And we have this arc making this sector. Okay, so I want the area of that sector. The radius, they tell me, is 22 inches. So I'm going to use this formula. Sector area out of pi r squared has to equal x out of 360. So I start filling in what I know. X is the 51 degree angle. The radius is 22. So I've got S over pi times 22 squared equals 51 for x over 360. And again, we cross multiply. So I've got 360 times the sector area, S, has to equal 51 times pi times 22 squared, okay? And again, to get S by itself this time, we want sector area. You divide the left side by 360, okay? And so we can type it in the calculator just like this, 51 times pi times 22 squared divided by 360. Now, if you were doing these calculations one at a time, you would have to start with the 22 squared. Remember your order of operations. But most graphing calculators and scientific calculators will do that for you if you enter it just like this. So that was 51 times pi times 22 squared divided by 360. As long as we're not dividing that exponent by 360, we're okay. And that's about 215.4. But these, this is an area measurement, so I want square units. Our units are inches, so that's square inches. Okay, so let's keep on going. Okay, we're using the same concept of arc length in these next few examples. In these next examples, we've got a given circle with a regular polygon inscribed inside. I want you to remember that regular polygon means that all the sides are the same. All the sides are congruent. And so what that gives us in each of these cases is a certain set of arcs as well, because each vertex of the polygon places a point on the circle and it splits that circle into congruent arcs because all the sides are congruent. They're equally spaced apart on the square in this case, so they're equally spaced apart on the circle. In this case, they tell me a radius of 18 is what I'm going to use on every one of these. Okay, so r equals 18. That's going to be important. So this is what the problem is asking you to find. It says find the length of arc AB, this should be an arc symbol, in the figure, given that points A and B are consecutive vertices. That means they're next to each other. They're not across from each other. So I could call this A, then this could be B, okay? I just need any two consecutive vertices. That makes this arc AB. It's a minor arc because there's only two letters. So that's my arc AB. They want the length of that arc. It looks like there's not enough information. In fact, it looks like I'm missing the central angle measure. So there's a short way to do this and a longer way to do this. I'm going to show you the long way so we can get to the short way. Okay? So we're still going to use arc length over 2 pi r equals x out of 360. Still going to do that. Okay? X in this case, I can kind of draw in my central angle that goes with this. If I were to do that for every pair of consecutive vertices, you can see pretty clearly each one of those angles. I took a full 360 and I split it into 4 equal parts. So that's 90. So each one of these is 90. So my central angle is 90. Well, now I have enough information to do the problem like I just did. That would be the long way. I told you I was going to show you that, or at least set it up here, but there is a shorter way to do this. Looking at this circle, every one of these arcs is an equal piece of the 360. Okay, that means every arc length is an equal piece of the circumference. So when I have a regular polygon inscribed in a circle, so only for these kind of problems, only for a shape inside a circle, the arc length is equal to circumference divided by the number of sides. Okay, so in this case, this would be circumference 2 pi r divided by the number of sides, or 2 pi times 18 divided by 4. Okay, so 2 pi divided by 4, sorry, 2 pi times 18 divided by 4 gives us an arc length of about 28.3. centimeters. So let's try that short version for the rest of these. Radius is still 18 for all these. Okay, in this case, A and B would be consecutive vertices like this, creating an arc. There's going to be 3 of those arcs. So I take my circumference, 2 pi times 18, and this time I divide by 3. Okay, so 2 pi times 18 divided by 3. Is about 37.7 centimeters. All right, to finish out our notes, on 5 and 6 here, I actually want you to pause the video and try and do 5 and 6 on your own using the same thing we were just doing. I'm still using radius equals 18 for both of these, but I want you to use that shortcut to find those answers, okay? When you're ready, click play to check your answers, and then we'll continue on with the last 2 examples. All right, if you need more time, go ahead and pause the video. Otherwise, this is what we should get. On number 5, the arc length for points, or for arc AB, 2 consecutive vertices, would be 18.8 centimeters. And for number 6, the arc length of arc AB between 2 consecutive vertices would be 22.6, because there's 5 sides to divide by on number 6, and there were 6 sides to divide by on number 5. Okay, so let's take a look at numbers 7 and 8. Okay, on number 7, this is a little bit different. It says find the radius. So we're looking for R. R will be my final answer. Get that out of the way. This time they give you the arc length, L, formed by a central angle is approximately 5.76. It's kind of misleading in the way they word it. They mention a central angle, but they don't tell you what the central angle is. They tell you the arc length is 5.76 centimeters. And the sector formed by that same arc has an area of approximately 15.8. They tell you the sector area is 15.84. So this time I'm giving you both of these, and we got to work backwards somehow and find S. Well, I want to review with you and go back to our formulas here. Arc length over circumference equals angle measure over 360 equals sector area over area. Well, guess what? We can eliminate this middle portion and set these two equal to each other. So that's kind of confusing to look at. So let me show you what I mean on the other page. So this is what I mean for number 7. The part of our proportion for arc length was L over 2 pi r. The matching part of our proportion for sector area was S over pi r squared. Because those are both equal to that middle piece, x over 360, they're equal to each other. Now, the reason I can do this is because now I can plug in this for L and this for S and work backwards and solve for R. There will be a shortcut we get to at the end, okay? But I want to work all the way through this one so you can understand the shortcut. All right? So if I cross multiply, getting ahead of myself, let's plug in our values. L was 5.76 over 2 pi r. That has to equal S, or 15.84, over pi r squared. I can cross multiply now. The only variable in this is r. It's just r squared on the right and just r on the left. We can cross multiply. Okay? So when I do that, again, I'm going to leave this unsimplified. I'm going to just list everything out. On the left side, I've got 5.76 times pi r squared. That has to equal the right side, 15.84 times 2 pi r. Now let me give you some helpful information with solving an equation like this and the algebra that's involved. First of all, there's a pi on both sides. You'll remember at previous examples, to cancel a pi on one side, you divide it by pi. We can do that here, but it's going to cancel on both sides. So I could just cancel it like that on both sides, okay? And when I do that, that changes my equation a little bit. It makes it look like this, 5.76 times r squared equals 15.84 times 2r. Well, now I've got an r squared on the left and an r on the right. In order to fix that, or to get r by itself on one side, we're going to take a little bit of a creative shortcut with the algebra. What we're going to do is we're just going to divide by r. Normally, you can't do that because dividing by a variable wouldn't work when that variable equals 0. However, this time r cannot equal 0 because it's the radius of a circle, and I can't have a circle with a radius 0. So I'm going to go ahead and divide by r on both sides. That's going to completely cancel it on the right, but r squared divided by r, I'll write it over here, r squared divided by r is like r times r divided by r. Remember, r squared is r times itself? Well, that's going to cancel one of them, but it's going to leave one of them. So the left side of my equation is now 5.76 times r equals 15.84 times 2. That's a whole lot easier to solve because all I have to do now is divide by 5.76. And I've left it unsimplified for a reason. R is now 15.84 times 2 all over 5.76. I'm going to get a final answer with this. I'm going to put it in the calculator, but I want you to see something first. $15.84 was our surface or our sector area, not surface area, sector area. And 5.76 was our arc length. So the radius ended up being equal to sector area times 2 divided by arc length. This is the shortcut formula we can use from now on. And so to actually plug that in, we're going to do 15.84 times 2 divided, let me look at that again, by 5.76, the arc length. And we get 5.5. Works out really nice this time. So that's my radius. Because the pi's canceled, it makes it a whole lot easier. So this shortened version of the formula for that radius, when I give you sector area and arc length, is what you can use. So for number 8, we're just going to use that shortcut. That radius is equal to sector area times 2 divided by arc length. Well, the sector area is 27.14. The arc length is 7.54. So I can just plug those in. Don't forget to do times 2 on the top. Okay? So 27.14 times 2 divided by 7.54. We get about 7.2. centimeters. Okay, so that finishes our notes for 6.2. After this lesson, after you've done this lesson in class, the next class there'll be a quiz. So before the 6.3 lesson, there'll be a quiz, but you will need to watch the next video as well before that class period just to make sure you're caught up. But this bell work will be your quiz review. Okay, so if you're watching this video before you get ready to take that quiz, make sure you've done the bell work for day 3 in your notes. That'll help you be prepared for the quiz.